the birth of the first extragalactic supernova about 2.5 million years ago, a giant star was dying. It was located in the Andromeda Galaxy, not far from its core. The final seconds of its life ended in a massive explosion. Trillions of tons of hot plasma blasted into space. This cloud instantly turned the nearest planets and moons into dust. A powerful electromagnetic pulse shot out in all directions. Millions of years later, this light would finally reach Earth. The year is 1885. Astronomers on Earth notice something amazing. A brilliant flash appears in the Andromeda Nebula. For a short time, it outshines all the nearby stars. This unusual supernova is named S Andromeda. Its strange features puzzle scientists for a long time. But just 6 months later, the star fades quickly. Soon, it disappears from the night sky forever. Unfortunately, back then, our understanding of the universe was very limited. Astronomers did not know how to measure distances to faraway space objects. Because of this, the bright patch in the Andromeda constellation, also known as Object M31, was seen as a simple reflection nebula. Scientists believed it sat on the very edge of our own Milky Way. However, telescopes became more powerful and technology improved. By the 1920s, observations by Edwin Hubble and his colleagues changed everything. They proved that the Andromeda Nebula was actually a completely separate galaxy. It was a massive system, very similar to our Milky Way. The structure and scale of our neighbor A century has passed since that discovery, and science has made huge progress. Today we know that the Andromeda Galaxy is a spiral galaxy. It holds about 1 trillion stars. Its diameter is over 150,000 light years. However, its mass is relatively small. It weighs between 800 billion and 1.5 trillion times the mass of our Sun. This is roughly the same as the Milky Way. Scientists believe this is because Andromeda has a huge number of lightweight red dwarfs and less dark matter like all spiral galaxies. Andromeda has a massive core at its center. This core contains millions of stars packed tightly together. Their light is so bright that it blinds our instruments. It makes it impossible to see individual stars. Because of this blinding light, the remains of the 1885 supernova were lost for a long time, even though old records showed exactly where to look. Finally, in 1988, 103 years after the explosion, scientists found it. They spotted a tiny nebula near the core. It looked like a dark spot against the brilliant center. By analyzing its light and motion, they confirmed it was S Andromeda. This object became the very first supernova ever discovered outside our own Milky Way. The mystery of the double core and the hidden X-ray monster. When you look closely at the center of Andromeda, you see a unique feature. Unlike other spiral galaxies, it has a strange double core. Scientists still do not fully understand how it formed. The bright part sits slightly away from the exact center. It is a giant cluster of bright stars spanning about 7 light years. The second part is closer to the true center. It is much dimmer and smaller, measuring about 1.3 light-years across. Scientists believe this dimmer area hides a supermassive black hole. This black hole is about 50 million times heavier than our Sun. The nature of this double center is a topic of hot debate. Some scientists believe that long ago, M31 swallowed a smaller galaxy. In this theory, the bright area is the leftover core of that captured galaxy. Other theories suggest that the center is actually one single structure. It only looks split because a thick lane of space dust blocks the light. Because Andromeda is so far away and tilted at a difficult angle, we cannot yet gather enough data to know which theory is right. If we keep exploring the central region, we find one of the most mysterious objects in this galaxy. Its complex catalog name is J004244.3 plus 411610. You can see it on the screen. The strange thing about this object is that it is practically invisible in a normal optical telescope, even a powerful one. But everything changes if you look through an X-ray telescope. In X-ray light, this object becomes the brightest point in the entire galaxy. Observations show that this is a binary system made of two objects, a neutron star. It is tiny, with a radius of just a few dozen kilometers. It spins incredibly fast, completing a full rotation in about 3 seconds. A companion star. This is a larger but dimmer object, most likely a red giant. The mass of this whole system is less than the mass of our Sun, and the two objects are extremely close to each other. Every 4 hours, the neutron star passes behind its companion. This blocks its powerful X-ray radiation, causing the brightness to drop sharply before returning to normal. Because they are so close, the neutron star constantly pulls material away from its companion. It is slowly eating the other star to grow its own mass. Calculations show this process will last for a few dozen million years. Eventually, the companion star will be torn apart by intense gravitational forces. It will turn into a bright, hot ring of gas. Anatomy of the disk: bulge, bar, and spiral arms. This strange X-ray object is just one of countless stars crowded around the core. Together they form a central bulge. This bulge is about 12,000 light-years wide and has a stretched oval shape. Andromeda also has a distinct central bar of stars. However, this bar is turned narrow-side toward Earth, making it almost invisible to us. It is about 17,000 light-years long and 6,500 light-years wide. In total, this central region holds about 30% of the galaxy's entire mass. As we move further out, we see that the ends of this central bar feed into two giant spiral arms. They wrap majestically around the center of Andromeda. Between these arms lie dark spaces. These gaps are much wider than the ones in the Milky Way, reaching up to 13,000 light-years across. The spiral arms contain about 56% of the galaxy's stars, along with some dark matter. Gravity pulls interstellar dust and gas into these arms, creating many star nurseries. Over time, these gas clouds turn into open clusters filled with a wide variety of young stars. Their bright light reflects off space nebulae, making the galactic disk glow with beautiful colors. The stellar chaos of Andromeda hidden among these bright clusters is another amazing star named Andromeda. It is one of the brightest stars in the entire galaxy. It is a hot blue giant, specifically a luminous blue variable. Its brightness changes randomly with no pattern at all. These objects are extremely rare. Today, scientists know of only a few dozen stars like this in the universe. Because of the extreme temperature and crushing pressure, the outer layers of Andromeda are highly unstable. The processes deep inside the star are chaotic and unpredictable. From time to time, massive streams of plasma collide, creating huge flashes. These flashes can change the star's brightness by dozens of times. The most powerful explosions can increase the star's brightness by several million times. This rare event is called a supernova imposter, and it could happen at any moment. Measuring a star this unstable from such a huge distance is incredibly hard. However, using modern high-precision telescopes, scientists have gathered some key facts. Its mass is between 50 and 120 times the mass of our Sun. At its peak, its radius expands to 55 times the size of the Sun. This is nearly as large as the orbit of Mercury. Its surface temperature is close to 20,000 Kelvin. Its brightness is 500,000 to 700,000 times greater than our Sun. Like all blue giants, Andromeda unleashes a fierce stellar wind. This wind travels at speeds up to 100 kilometers per second. Because of this, the star blasts about 2 quadrillion tons of its own material into space every single second. This means every year it loses a mass equal to about 9 Earths. However, for a star this size, that loss is barely noticeable. Andromeda will finish its life long before it loses even a tiny fraction of a percent of its mass this way. Even though it is only 2 million years old, which is very young for space, it has already lived most of its life. Calculations show that within the next million years, this star will explode as a real supernova. It will leave behind a black hole surrounded by a vast cloud of gas. Age zones and life in another galaxy studying the stars in M31 shows a clear pattern based on age. The oldest stars are around 11 to 12 billion years old. They are packed tightly in the central part of the galaxy. In contrast, the flat disk and spiral arms mostly hold younger stars. These formed about 3 to 4 billion years ago. Finally, the gas and dust nurseries hold newborn stars that are only a few million years old. This tells us that early in its life, Andromeda was much smaller and shaped like a simple ellipse dot. By analyzing these different stars, scientists can map out the galactic habitable zone. This is the region where life could potentially exist. The central region. The star density here is extreme. The intense radiation and unstable planetary orbits make it a terrible place for life to form. The outer edges, The outer parts of the galactic disk lack heavy chemical elements. Because of this, it is very hard for solid, rocky planets like Earth to form there. The middle region. Only the middle zone of the galactic disk provides the right balance for life. Right in this safe zone, about 20,000 light years from the center, sits a small, dim star called PA 99N2. It is a red giant with a relatively small mass. About 50% of our Sun. In 1999, a rare event called microlensing happened. The gravity of a closer object acted like a magnifying glass, allowing astronomers to study this distant star in detail. They measured its mass, its light spectrum, and its surface temperature, which is about 3,700 Kelvin. The most exciting discovery was a rhythmic wobble in the star's movement. This kind of wobbling usually means a star has a heavy companion pulling on it. This hidden object is called PA 99N2b. If its existence is fully confirmed, it will officially be the first exoplanet ever discovered in another galaxy. We do not have much data on it yet, but calculations suggest it is a massive gas giant. There are also signs that this system has a rich mix of chemical elements, much like our own solar system. This means there is a good chance it holds different types of worlds, not just gas giants, but rocky planets similar to Earth. Monster clusters and cosmic cannibalism. When you look at Andromeda, you immediately notice its massive number of star clusters. It has far more than the Milky Way. In total, M31 has about 460 dense globular clusters, around 10,000 open clusters, and dozens of larger stellar associations. One of the largest and most famous structures is a giant cluster named NGC206. It sits on the very edge of the galactic disk. Scientists used to think it was a regular globular cluster, but because it is so huge, it was upgraded to a stellar association. Inside a space with a radius of about 200 light years. It holds roughly 300 incredibly bright stars, along with countless smaller ones. Its total mass is around 200,000 times the mass of our Sun. Their combined light is so powerful that you can see this cluster from Earth using a basic backyard telescope. Observations show that NGC 206 was born when at least two massive clouds of gas and dust crashed into each other. One cloud was about 10 million years old, and the other was much older, around 50 million years old. Their collision created a powerful gravitational pull, drawing in more gas and triggering a massive wave of star births. Over time, some of these stars will drift away into space, while the rest will form a large globular cluster. The galactic disk of M31 contains many structures like this, and not all of them were born there. Scientists believe that many large star clusters are actually the leftovers of ancient cosmic mergers. Calculations show that over its lifetime, Andromeda has swallowed more than 100 smaller neighbor galaxies. Some dissolved without a trace, while others turned into long streams of stars stretched across space. The crash with M32, and the ultimate end, the most violent and dramatic collision, was with a galaxy called M32. This compact galaxy sits right above the disk of Andromeda, just 17,000 light-years away. It is small, with a diameter of only 8,000 light-years. But for its size, it is incredibly heavy, weighing about 1 billion times the mass of our Sun. Even more surprising, its center holds a supermassive black hole that is 2.5 million times heavier than the Sun. This is shocking for such a tiny galaxy dot in reality. M32 is just a broken remnant of a much larger galaxy that survived a massive disaster. Data from the Spitzer Space Telescope prove that about 800 million years ago, this large neighbor smashed right through the disk of Andromeda at high speed. It left a massive hole in one of Andromeda's spiral arms. During this violent crash, M32 lost most of its outer stars, and we can no longer tell what it originally looked like. It was likely a full-sized elliptical or spiral galaxy, but now only its dense core remains. Besides M32, Andromeda has about 30 other satellite galaxies bound to it by gravity. The largest and brightest is M110, which is about 15,000 light-years wide. Most of the other satellites are tiny dwarf galaxies scattered within 1 million light-years. Together, they form the Andromeda subgroup. This subgroup is part of our local group of galaxies. The other main members of this cosmic neighborhood are our Milky Way and the Triangulum Galaxy, also known as M30-3. The pull of gravity is steadily drawing the entire local group together. Because of this, the Andromeda Galaxy is rushing straight toward us, closing the distance by over 300 kilometers every single second dot in a few billion years. Andromeda will inevitably crash into the Milky Way. This massive collision will blend the two systems together to create one giant elliptical galaxy. Powerful gravitational forces will mix billions of stars from both sides, scattering them across a brand new cosmic landscape. By that time, our own planet Earth will already be scorched by our aging, expanding sun, or it might be swallowed entirely by a sea of hot plasma. What will happen to humanity by then is impossible to predict. Will we escape to other star systems, or will evolution change us completely? For now, that question remains unanswered.